So here it says to find the second derivative with respect to x. Leave your answer in terms of x and y. Okay, so we're going to have to use implicit differentiation here because we don't have y solved for. I suppose we could solve for y, but then you have a plus or minus kind of thing going on, and I don't want to do that. So I'll just use implicit differentiation, and I'll take the derivative of this. But first, I'm going to change things around a little bit. It's easier. I mean, you could use quotient rule on this, and that would be fine, but I prefer not to. So I'm just going to have this. And then I'll take the derivative. Remember, if you're taking it with respect to x, anytime you take a derivative of a variable that's not x, you take the derivative like normal, and then you tack on a dy dx. That's because of the chain rule. But here we go. So derivative of 2y, take it like normal. Sorry, derivative of y squared is 2y. And then tack on a dy dx equals derivative of 1 is 0. Derivative of this, just use the power rule. Bring that down. That will be positive 2x to the negative 2. And then solve for dy dx by dividing both sides by 2y. I'll bring the x down. So it'll be 2y x squared. That goes away, and I have dy dx equals 1 over x squared y. And then again, because I know I'm going to continue taking the derivative, I'm going to use, again, I could use quotient rule, but if I can avoid it easily, I'm going to avoid it. So now that I have dy dx solved for, I can just take the derivative again. And here I'll use the chain rule because of that negative one there. I'll bring it down and I'll do that. And then on the inside is just a product rule. So d squared y dx squared, that's going to be negative 1, I'll say. And then negative 2. So the derivative of the outside with the inside the same, times the derivative of the inside. That's product rule because I have two things being multiplied. So that's first. D second is dy dx. First d second plus second. What's the second one? Second y. Second d first. This product rule. Okay, that's pretty easy. And then technically we don't have to distribute, but I'm going to distribute anyway. So actually, let me just rewrite some things here. So what would I have? I would have, let's say, a negative 1 in the top, x squared y. Actually, it would be x to the fourth y squared, right? If I distributed those. Of course it would be. And then is x squared times dy dx. Remember, dy dx is this. 1 over x squared y. And then plus 2xy. I don't know why that one's in red. And yeah, then I'll distribute this stuff and see what I get. I'm just simplifying here. So I get d squared, dx squared, that's on the bottom. And I just get, this piece simplifies with that, so I get, that goes away. This changes to 2. And then I'm multiplying it, so it really stays, why didn't I just cancel it out right there? That goes away, right? And then I just have y cubed on the bottom, so I get negative 1. It's going to be in red. I don't want to change it. Negative 1 x to the fourth y cubed. And I distribute it one more time, and that would become a minus 2, and then the x would be x to the third. And then just y. Yeah? Yeah. And there you go, the second derivative in terms of x's and y's.